Welcome students. Today in exercise 1.4 we are going to see sum number 3. If f of alpha, a given matrix, you are asked to show that f of alpha the whole inverse is equal to f of minus alpha. Can you understand? F of alpha is given a matrix. You are asked to prove that or show that f of alpha the whole inverse is equal to f of minus alpha, right? So this is an important note, so always keep that in mind. This will help you in most of the places, and using this hint we are going to see most of the problems in this exercise, right? See, A is a matrix. That means A inverse is what? It's the inverse of A matrix. A and A inverse. When you product the two, that will give you an unit matrix, okay, of order n. The same way, A inverse into A will also give you a unit matrix. Okay, you know that in matrix, multiplication of matrix, commutative property does not work. So it is A into A inverse and A inverse into A, both are checked here, and that gives you a unit matrix. Okay, right. Now in the question you are asked to prove this, isn't it? F alpha, that means f of alpha the whole inverse is equal to f of minus alpha, isn't it? Now to finding inverse is little bit a difficult task, isn't it? That means adjoint, and then you have to find the determinant and all. So that we are going to use this particular note here, and we are going to do it. So to eliminate this inverse, since finding inverse is a little bit a tedious task, so we are going to avoid that. Okay, so to remove this inverse here, when you multiply by A, you will get an unit matrix. The same rule is going to be applied here, right? So here also, to remove this inverse, I have to multiply by what? Here A inverse, so I have multiplied by A. This is f of alpha the whole inverse, so I have multiplied by f of alpha, right? Pre-multiply. Okay, so I am going to multiply in the front, so pre-multiply by f of alpha on both the sides. So f of alpha here and also f of alpha here in both the sides. So you know that A inverse is I, so here also the matrix and its inverse. Okay, so we can take this as I have written on the right hand side. Okay, this is what I, unit matrix, and this has been written on the left hand side. Now we are going to prove only this. So proving this is extending that we have proved this. Okay, so it is enough to prove this. So this is very simple, only producting the two matrix, product of two matrix. Can you understand? So now we are going to find this, right? F of alpha. So f of alpha matrix is already given here. F of minus alpha. So minus alpha means what? Alpha is replaced by minus alpha. So this matrix, in this matrix, all the alpha should be replaced by minus alpha and to be written next. So cos alpha is cos minus alpha, sin alpha is sin minus alpha. Similarly, in these two places also we have replaced, and this is written as it is. And you know that cos minus alpha is cos alpha. Last year we learned. So cos minus alpha is cos alpha, sin minus alpha is minus sin alpha. Can you understand? Cos minus alpha is cos alpha, sin minus alpha is minus sin alpha, right? Now here already there is a minus, so when you make it as minus sin alpha, minus into minus becomes plus, so that's why I put plus here. Can you understand? So here also cos minus alpha is cos alpha. Now we have to product the two matrices. Okay, so cos alpha, cos square alpha, 0 into 0 plus 0, sin alpha into sin alpha, sin square alpha. Then cos alpha into 0 is 0, 0 into 1 is 0, sin alpha into 0 is 0. Cos alpha into minus sin alpha is minus sin alpha cos alpha, 0 into 0 is 0, plus sin into cos is sin alpha cos alpha. Now 0 into cos alpha 0, 1 into 0 is 0, 0 into sin alpha is 0, 0 into 0 is 0, 1 into 1 is 1, 0 into 0 is 0, 0 into minus sin alpha 0, 1 into 0 is 0, 0 into cos alpha is 0. Now minus sin alpha into cos alpha is minus sin alpha cos alpha. 0 into 0 is 0. Cos alpha sin alpha is plus sin alpha cos alpha, right? So sin alpha into 0, it's 0. 0 into 1 is 0. Cos alpha into 0 is 0. Minus sin alpha is plus sin square alpha. 0 into 0 is 0. Cos alpha into cos alpha is cos square alpha. We know that sin square theta plus cos square theta is 1, isn't it? We learned in 10th standard also. Sin square theta plus cos square theta is 1. So sin square alpha plus cos square alpha is 1. This is 0. Here it is cancelled. Here it is 0. This is 1. And here again it is 0. Then here also it is cancelled. Both the thing is cancelled. And this is 0. And this is sin square plus cos square alpha is 1. This is nothing but what? It's a unit matrix. So from here we understand that f of alpha into f of minus alpha is equal to a unit matrix. So therefore f of alpha the whole inverse is equal to f of minus alpha. Hence we prove that. Exercise 1.1, sum number 4. If A is a 2 by 2 matrix, show that a square minus 3a minus 7 into I2 is equal to O2. Okay, hence find A inverse. So this I2 is an what? It's a unit matrix. O2 is a 0 matrix. Okay, fine. Right, now a 2 by 2 matrix is given. This particular part we already learned. We have done in 10th standard and also in 11th standard. But still I will go with that. The solution, first we have to find what? A square. What is A square? A matrix into A matrix. So A matrix into A matrix. I am going to find the product. 5 into 5, 25. 3 into minus 1 is minus 3. 5 into 3 is 15. And 3 into minus 2 is minus 6. Minus 1 into 5 is minus 5. Minus 2 into minus 1 is plus 2. Minus 1 into 3 is minus 3. Minus 2 into minus 2 is plus 4. So it is 22, 9, minus 3 and 1. So this is A square. Now the second part, the final part is A square minus 3a minus 7i2, which is equal to A squares already we have found, that is written here. Minus 3 into A matrix is written, minus 7 into what? It's a unit matrix. Okay, now multiply this minus 3 inside, so to all the elements in the matrix. So it is minus 15, minus 9, plus 3 and plus 6. In similar way, bring this minus 7 inside the unit matrix. So it is minus 7, 0, 0, minus 7. Now you can add it. 22, minus 15, minus 7 is 0. 9 minus 9 plus 0 is 0. 3 minus 3 plus 0 is 0. 1 plus 6 minus 7 is 0. Okay. So finally all the elements are 0. So it's a 0 matrix. So hence we proved that. Now in the question you are asked to find A inverse. But hence it is given. Hence means we have to find A inverse from this particular statement. Okay. So same concept. What we have done, to find inverse we have to do what? Previously we have seen A into A inverse is equal to A inverse into A is equal to I. The same property is going to be done here. So I am going to pre-multiply by A inverse on both the sides. Okay, so this A square is written as A into A. So pre-multiplied by A inverse. Here also pre-multiplied by A inverse, and this term is also pre-multiplied by A inverse, and this is also pre-multiplied by A inverse. Okay, so A inverse and A I just group together, and you know that this is interchangeable. See, very important thing is you cannot interchange two matrices because commutative property sometimes won't work. AB is not equal to BA, isn't it? So you cannot interchange two matrices, but you can interchange. That means you change the place of a matrix and a number. Okay, so that doesn't matter, right? You cannot interchange these two matrices, right? So A inverse into 3 is a number, so I can interchange this. Here also A inverse into 7 is a number, I can interchange this. And 0 matrix, when you multiply with any matrix, it is completely, it's a 0 matrix again. Okay, fine. A inverse into A is what? I. Since it's a 2 by 2 matrix, I put I2. And this is here also A inverse into A is I2. And this is A inverse into I2 is A inverse. Okay, just like multiplying a number, what is I2 is considered like 1. When you multiply any number by 1, you will get the same number. Like that way, when you multiply any matrix by M, unit matrix, you will get the same matrix. Keep that in mind. In such a way, here also when you multiply any number by 0, you will be getting only 0. Same way, when you multiply any matrix by a 0 matrix, you will get 0. So these two things you keep it in mind, means it's very simple to prove this. Okay, now I told that when you multiply any matrix with I, it's the same matrix. Here it is a number only, so you cannot remove this I2, so it is minus 3I2. This is 7 into minus 7 into A inverse. I can take it to the right hand side, so it becomes plus 7 into A inverse. When you add with 0 matrix, you will get the same only. So this thing I have written in the left hand side, and the A minus 3 I2 is written on the right hand side. So now the question you are asked to find A inverse, so bring this 7 to the right hand side, it becomes 1 by 7 into this is A, okay, A minus 3I2. So to find A inverse, we have to subtract 3I2 from the A matrix and divide by 7. So 1 by 7, this is A matrix, minus 3 into what is unit matrix. So 5 minus 3 is 2, 3 minus 0 is 3, minus 1 minus 0 is minus 1, 2 minus 3 is minus 5. So A inverse is 1 by 7 and this matrix. Exercise 1.1, sum number 5. If A is equal to 1 by 9 into a 3 by 3 matrix, prove that A inverse is equal to A transpose. So previously I told that in a 3 by 3 matrix, A inverse, it's a little bit difficult to find it at today's task. So what you have to do is just eliminate this. To eliminate this, what do you have to do? Pre-multiply or post-multiply by A. So this is the statement. I'm going to pre-multiply by A on both the sides. So A into A inverse, A into A transpose. A into A inverse is what? I3. Since the 3 by 3 matrix, I put I3. The A into A transpose is as it is. So here it is easy to prove this. That means when you multiply A matrix with its transpose matrix, you will get what? Unit matrix. So proving this, we are extending and we are proving this. Okay. So A into A transpose. Okay. So 1 by 9 into the matrix is written. A transpose 1 by 9, just the transpose. This is written here. Second row is made into second column and third row is made into third column. Okay. Now you see here 1 by 9 into 1 by 9. Okay, it's a number, so I can multiply and put it together. This can be interchangeable, but these two cannot be interchangeable. So 1 by 9 into 1 by 9 is 1 by 8 9. The two matrices are written nearby. Now we have to multiply. So minus 8 into minus 8 is 64. 1 into 1 is 1. 4 into 4 is 16. Minus 8 into 4 is minus 32. 1 into 4 is 4. 4 into 7 is plus 28. Minus 8 into 1 is minus 8. 1 into minus 8 is minus 8. 4 into 4 is 16. 4 into minus 8 is minus 32. 4 into 1 is 4. 7 into 4 is 28. 4 into 4 is 16. 4 into 4 is 16. 7 into 7 is 49. 4 into 1 is 4. 4 into minus 8 is minus 32. 7 into 4 is 28. 1 into minus 8 is minus 8. Minus 8 into 1 is minus 8. 4 into 4 is 16. 1 into 4 is 4. Minus 8 into 4 is minus 32. 4 into 7 is 28. 1 into 1 is 1. Minus 8 into minus 8 is plus 64. 4 into 4 is 16. So this is altogether 81. This is 0. This is again 0, 0, 81, 0, 0, 0 and 81. So here we have an 81. So I can take 81 from this matrix, from all the elements. So here there is no 81. It means nothing but 0 into 81 is 81. So I can take it. So taking all 81 from all the elements, 81 and 81 cancel. So I got a unit matrix. So we proved this. From this we say that A inverse is equal to A transpose. Exercise 1.1, sum number 7. Okay. Now here two matrices are given, that is A matrix and B matrix. You are asked to verify AB whole inverse is equal to B inverse into A inverse. Okay, since this is 2 by 2 matrix, we can easily do it. Okay, fine. Now first we have to find, the formulas, right? So first we have to find determinant A and determinant B. Determinant A is 3275. The same is written. Removing the square bracket, you have to put a vertical bar. So 3 into 5 is 15, minus 7 into 2 is 14, which is equal to 1, which is not equal to 0. That means A inverse exists. That means you can find A inverse. Similar way, determinant B is written here. Minus 1 into 2 is minus 2. Minus 5 into minus 3 is minus 15. So minus already is there. So it is plus 15, which is equal to 13, which is not equal to 0. So B inverse exists. You know how to find A inverse. It's 1 by determinant A into adjoint A. So 1 by what is determinant A is 1. So 1 by 1. Adjoint A, how to find it? Just interchange the two elements in the main diagonal. So 5 goes here and 3 comes here. Change the sign of 2 is minus 2. Change the sign of 7, which is minus 7. So leave this 1 by 1 I have written here. Now B inverse. And how to find B inverse? That is also very simple. 1 by determinant B into adjoint B, which is equal to 1 by determinant B already we have found, which is 13. So 13 into adjoint A. Just interchange the two elements. So 2 and minus 1. Sign of minus 3 is changed as 3. 5 is changed as minus 5. Now B inverse into A inverse. So B inverse is written here and A inverse is written here. Multiply it. 2 into 5 is 10. And 3 into minus 7 is minus 21. 2 into minus 2 is minus 4. 3 into 3 is plus 9. Minus 5 into plus 5 is minus 25. Minus 7 into minus 1 is plus 7. Minus 5 into minus 2 is 10. Minus 1 into 3 is minus 3. So which is minus 11, 5, minus 18 and 7. Take this as 1. Right? Now we have to find AB whole inverse. For that I have to find A into B, product of the two matrices. Two matrices is written. Now we have to find the product of the two matrices. Right? Now multiply the two matrices. 3 into minus 1 is minus 3. 2 into 5 is plus 10. 3 into minus 3 is minus 9. 2 into 2 is plus 4. 7 into minus 1 is minus 7. 5 into 5 is 25. And 7 into minus 3 is minus 21. 5 into 2 is plus 10. So which is 7 minus 5, 18 minus 11. Now we have to find determinant AB. So change the determinant sign. 7 into minus 11 is minus 77. Minus 18 into 5 is minus 90. So minus into minus plus 90. So we have got 13, which is not equal to 0. That means we can also find AB whole inverse. That means AB whole inverse exists. So AB whole inverse is what? 1 by determinant AB into adjoint AB. Okay, 1 by determinant AB is, that is 13. So 1 by 13. Adjoint is what? We have to interchange the two elements. So minus 11 and 7. Minus 5 becomes plus 5. Plus 18 becomes minus 18. So now from 1 and 2, statement 1 and statement 2, we have to prove, we proved that from 1 and 2 AB whole inverse is equal to B inverse A inverse. I'll show you what is 1 also. See here, 1 and 2 both are same. So from this we can say that AB whole inverse is equal to B inverse into A inverse. Exercise 1.1, sum number 13. Given three matrices, A matrix, B matrix, C matrix, 2 by 2 matrices. Find a matrix X such that A matrix into X matrix into B matrix is equal to C. You suppose not to change this order, is very important. So here also we are going to use the same note. What is A inverse into A is equal to A into A inverse, which is equal to what? I. Right? Okay. Now here I want to remove, see, this X to be found. So I have to remove this A and remove this B. To remove the A, I have to pre-multiply by A inverse so that it becomes I. So I can easily remove A. Okay, so pre-multiply by A inverse on both sides. So A inverse on both sides we multiplied. A inverse into A is I into X into B, which is equal to A inverse into C. You know, when you multiply unit matrix with any matrix, it becomes the same matrix. So X into B is equal to A inverse into C. Now what do you have to do? We have to remove this B. So we are supposed to multiply what? B inverse. Okay, so first multiply by B inverse on both the sides. So B inverse and B inverse on both the sides we have post multiplied. Now B inverse into B inverse is I. So this is as it is. And X into I is, you know that, which is X. So to find X, what we have to do? Multiply, first multiply C with the A inverse. Then with that matrix multiply B inverse. So first we have to find A inverse and B inverse. So to find A inverse, we have to find determinant A. So determinant of that matrices, 1 into 0 is 0, minus 2 into minus 1 is minus 2, which is plus 2, which is 2, which is not equal to 0, A inverse exists. Now determinant B, 3 into 1 is 3, minus 1 into minus 2 is minus 2, so it is plus 2. So 3 plus 2 is 5. So this is also not equal to 0, so B inverse exists. A inverse is equal to 1 by determinant A into adjoint A. Determinant A is 2, so 1 by 2 into, interchanging the two elements, 0, 1, minus 1 becomes plus 1, 2 becomes minus 2. Now B inverse. B inverse is equal to 1 by determinant B into adjoint B. What is determinant B? Which is 5. So 1 by 5 into adjoint B. Interchange 3 and 1. So 1 and 3. Minus 2 becomes plus 2. 1 becomes minus 1. So we know this is the statement. So A inverse is this matrix written here. C is already given. That is also written. B inverse is this matrix. This is also written. And you know that we can bring this 1 by 5 in the front. So 1 by 2 into 1 by 5 is 1 by 10. I'm going to product these two matrices. 0 into 1 is 0. 1 into 2 is 2. 0 into 1 is 0. 1 into 2 is 2. Minus 2 into 1 is minus 2. 1 into 2 is plus 2. Minus 2 into 1 is minus 2. 1 into 2 is plus 2. Okay, the same thing will be repeated on both sides. So this is the matrix we have got, and this B inverse part is also written here. Now we have to add it, which is 2. This is 0 and this is also 0. Now we have to find the product of these two matrices. So 2 into 1 is 2. 2 into minus 1 is minus 2. 2 into 2 is 4. 2 into 3 is plus 6. 0 means all is 0. So here also all are 0. So 2 minus 2 is 0. 4 plus 6 is 10. It is 0 and 0. Since we can take 10 outside, even though 3 zeros, 0 into 10 is 0 only. So I can take 10 outside, cancelling. I have got 0, 1, 0, 0. So this is what the value of X matrix. That's all. Thank you.